Day 808 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1260, shift 2D grid. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Sorry, y'all. Hold on. Given a 2D grid of size n by n and an integer k, you need to shift the grid k times. In one shift operation, element at grid of ij moves to grid of ij plus 1. Element of I n minus 1 moves to grid of I plus 1, 0. And an element at grid of m minus 1 and n minus 1 moves to grid of 0, 0. Return the 2D grid after applying the shift operation k times. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just so we can get an idea of what we're doing. So in example 1, we have our input grid equals a 2D array of integers, or a grid, first array being 1, 2, 3, then 4, 5, 6, then 7, 8, 9, and k equals 1. It's important to point out that each array represents a different row in the input. So this is the top row, this is the middle row, and this is the bottom row, right? And then this right here would be the top row of the output, the middle row of the output, and the bottom row of the output. And yeah, the output is a 2D array of integers, first array being 9, 1, 2, then 3, 4, 5, then 6, 7, 8, y'all. So boom, just in case that didn't make sense, let's take a look at example 2. Or just to break this down one step further, though, so you can see what's going on, we just shifted this array by 1 because k equals 1. So we moved this 9 up here to this corner, and everything else got shifted to the left, or excuse me, to the right by 1. So now this 1 is here, 2 is here, and the 9 would be here, like this. 9, 1, 2. Everything got shifted to the right one once we took this 9, looped it around over here. Boom. So let's take a look at example 2. In example 2, our input grid equals a 2D array of integers. First row is 3, 8, 1, 9. Next row is 19, 7, 19, 7, 2, 5. The next row is 4, 6, 11, 10. And then the bottom row is 12, 0, 21, 13. This time k equals 4, so we have to shift this by 4. This is what we have at first. So first, you see, we take this 13, we move that up here. Boom. Then we take this 21 and we move this up here and shift the 13 to the right. Then we take this 0, boom, and put it up here and shift the 21 and 13 to the right. Then we take this 12, boom, loop that around right here, and we move the 0, 21, and 13 to the right until this is our final output right here, a 2D array of integers, or a matrix, n by n matrix grid. First row being 12, 0, 21, 13. The row under that is 3, 8, 1, 9. The row under that is 19, 7, 2, and 5. And the row under that is 4, 6, 11, and 10. Boom. Now, I'm not going to go through example 3 because it has 9 shifts and they do not give us a picture of those 9 shifts, and I don't want to confuse y'all any more than y'all already are. So if you want to go through this, I suggest you go through it yourself, sort of like a homework question. Now that we understand the question, y'all, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing, if there are no shifts requested, then we just need to return the original grid. So we could just say if k equals 0, then we could just open up the brackets and return. Actually, let's turn this grid up here first. We're going to turn that into G, and then we could just return G. Now, I'll tell you why we did that in a minute. But first we need to determine, or we need a constant to determine the number of rows and columns. So we'll say let row equal g dot count, comma, call equal g square bracket 0 dot count. Boom. And then this is going to tell us how many columns, and this is going to tell us how many rows. Boom. Then we need to create a copy of the original grid that will hold the shifted value. So this is why we changed this to G, because we are going to make that G mutable, and we're going to call it grid once we mutate it. So we could declare a variable called grid, set that equal to G. Then we're going to visit every cell in the original grid. So we're going to say for r in 0 dot dot less than rows, we're going to open up the brackets, and we're going to say for c in 0 dot dot less than call. We're going to open up the brackets, and we're going to compute the new row after shifting the element k positions. So c plus k divided by call is going to determine how many times the shift wraps past the end of the current row. Adding that to r moves the element down by an appropriate number of rows. Then the modulo wraps back around to the top if necessary. So we'll say let rw1 equal, open up the parentheses, r plus, open up some more parentheses, c plus k, come outside of that, divide that by call, come outside of that, and we'll say mod row. Boom. Then we're going to compute the new column after shifting. The modulo wraps the column back to the beginning whenever it moves past the last column. So we're going to say let CL1 equal, open up the parentheses, C plus K, come outside of that, and we're going to say mod call. Boom. Then we're going to place the current value into its new location by coming underneath that. We're going to say grid, square bracket RW1, square bracket, come outside of that, sorry, y'all, square bracket CL1, come outside of that, equals grid, square bracket R, square bracket C. Boom. Now we're not done yet, because we need to return the shifted grid by coming right here, and we can say return grid, y'all. Boom. That's all she wrote. Let's give it a run. Make sure it runs properly. Okay, so this should be row, not rows. So now let's give it a run, see if that fixed it. Should have. Hopefully it did. It's got the wrong answer. So when we get the wrong answer, most of the time that means that the math is not mathing. So let's check where we did our math. So we got R plus C plus K divided by call mod row. Then we got C plus K mod. Oh, sorry, y'all. I know what it is. This should be G of R of C, not grid of R of C. So now let's run that again, see if that fixed it. It's accepted this time. So now let's go ahead and submit it. Make sure it's still accepted after we submit it. Ooh, and look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So before we go, make sure you get one more look at the code. And yeah, y'all, with that being said, I hope y'all learned something today. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.